So hello guys, I'm back with another new and interesting video. So today we are going to solve the question number 3007 of LeetCode. Code. What this question says we need to find the maximum number that sum of the price is less than or equal to the value k. So basically what this question says is that basically they have given you two values. One is the long k and one is the integer x. So we have to perform some operation on the we do some perform the, some operation on natural number and need to find something. So let's just explain these things with one example. So I prepared something for you. So before explaining the question, I just want to explain you one concept here. So see here, the binary representation of zero is this. Binary representation of one is like this. Means I have represented all the binary representation from number 0 to 16. You can notice one thing that here at first bit first bit of every number is varying like this 0 1 0 1 0 1. And second binary bit is repeating like 0 0 1 1 0 0 1 1. Means you can catch some pattern from this thing that the first bit if in first bit at first bit means in at first bit you always get one set bit means one set bit. If you if you take two, in second set bit you will always get two set bit. When you take four in third bit you will always get a fourth set bit. When you take eight eight number starting from zero. So in this way we can say that we can means basically let me now explain you the question. What this question says. So sorry. Okay. So they have given you two value. One is x and one is k. So what you have to do is you have to choose any number n such that the number between such that the number between such that okay, give me time. You have to choose you have to choose any number n, hmm, such that the number between 1 to n contain contain k set bit or less than k set bit. So here is the question. Let me do it for you. So basically you are given an integer k and an integer x. So what do you have to do? Suppose here we have choose the value 13. And what this x means is that you have to choose the we have to choose the bit position 1 and multiple of ones. So here you can clearly see that they want the sum of those bits, some of those set means they want only those set bit which are the multiple of x. So in the case of 13 and for x is equal to 1, the bits which they want is that means the multiple of ones are it means the multiple of 1 is like 1 2 3 4 and 5. These are the multiple of 1 now. So that's why so that's why it covers all bit, or it means it covered all binary representation of that 13. Now if the x value is 2, so the bit position which we can include in our counting is that 2 4 6 and 8, because it is multiple of 2. In the same way here also, when x is equal to 2, the bit position which we can include in our counting is that 2 4 6 and 8. In the case of 3, we can what we can when which bits can we can include in our counting, which is means the bits number are 3, third bit, sixth bit, and ninth bit. Means what we have to do is that Basically, we have to include only those bits of any number which is multiple of that given x. Hmm. Which are the multiple of given x. So let me pick you one number. Hmm. Suppose here n is equal to 6. Hmm. N is equal to 6. Hmm. And we have to find the set bit. We have to find the number of set bit from 1 to 6, where x is equal to 2. X is equal to 2 matlab x is equal to 2 means that we can only choose that positions which are the multiple of 2. So the positions are, so 6 is here now. So 6 is this now. So we can choose this bit, this number bit, because it is here. This is the second position and this is the fourth position. So we can choose this one. So we have to count the number of set bit at a multiple of x positions. Hmm. So here the set bits are the number of set bits are 1, 2, 3, 3, and here there is no set bit. So the k will be 3. Hmm. For this case. So what this basically what this question says is that you have given some k value, and then you have to find the any natural number n such that the such that the counting of all set bit from 1 to n must be less than or equal to k. Hmm. You have to find the greatest integer n such that the number such that the sum of all set bit at multiple of x position means at multiple of x at position multiple of x, like if suppose if x is 2, then the position which we can include is 2, 6, 2, 4, and 6 and 8, like this, until if long, if it is long, then we can go up to 64. So don't so we can include those bit position or those bit position which are the multiple of x. So we have to find the integer n. So let's see the example. So here we have given value k is equal to 9 and x is equal to 1. So what this x is equal to 1 means that we can only include that set bits which are the multiple of 1. Means the multiple of what are the multiples of 1? Multiples of 1 are 1, 2, 3, 4, 5, 6. These are the multiples of 1 now. So we can from this we can we can we get to know that we can include all the bits. So what we have to do here is that we have to find the 9 set bit, means the largest integer value up to which means largest integer value up to which we can get less than or equal to 9 set bits. Hmm. So here count here. Into there is no set bit, so there is means nothing means we are still less than k is equal to 9. Hmm. Now in one there is one set bit, so our count value is, see here this is suppose this is the count. Hmm. So our count value increases to 1. Now when n is equal to 2, there is only one set bit, so our count value increases to 1. So now when n is equal to 3, there is 2 set bit, so our count value increases by 2. Hmm. When n is equal to 4, our count value increases by 1. Now our count increases by 1. Now our count become 5. When our n is equal to 5, when we are on n is equal to 5, then our count value will be increased by 2. So our current count is now 7. And when we are n is equal to 6, our current count is increased by 2. Now the current value is current value is 9. So what we get to know that the 6 is the largest number up to which we can get k is equal to 9. Means 6 is the largest integer. Uh, means 6 is the largest integer in which all the set bit are count of the set bit are less than 9 at the position which is a multiple of x. So these are the things which we have to do. So the basic concept is that means the things is that how we can solve is that suppose they are means basically they are going to give us the value x, and that is the problem. That is the main problem in this question. So what we have to do, we have to just think about the value x, how we can handle this x for each cases. And the constant is given that the k can be 10 to the power 15 and x can be from 1 to 8. So so suppose hmm, suppose k can be 10 to the power 15 means, and it is also given that the return type should be long. So from this we can predict that the n can be means the integer number can be of long data type. So my first thought is that why shouldn't we apply binary search? Means why shouldn't we apply binary search? Means suppose from 1 to 10 to the power 15, from 1 to 10 to the power 15. Let's choose any mid value, and then let's choose any mid value. Let's choose mid value between 1 to 10 to the power 15, and then let's uh, perform the operation like counting the set bits from 1 to that mid value. After counting, if it satisfied, if it satisfy the value k, if it satisfy or it is greater than value k, then what we have to do? We have to reduce our ranges from one to mid, uh, one to mid, and then after that after that we are gonna find mid two, which will be which may be lie between which may be lie between one to mid. Means you must know you must have to know the concept of binary search, how this binary search is going to be applied. So this way we can really get to that number which really satisfies this given condition. Which really satisfied this all the operation what we have means what the set bit means, what this counting, what this question needs. So basically my logic is that I am starting with left value with 1 and the right value to keep our 253. Means I think this will be enough to get all the test case, means up to handle all the test cases. So here I have applied binary search operations. Binary search operation. First I have find the mid value. You are very familiar with this term because if you know the binary search, then you must know how to find this mid value. After that, if I after that after getting the mid value, I have just I've just called the function operation. Means what this operation function going to do is that it basically counts the it basically count the number of set bit from number of set bit at multiple of x positions from 1 to that value mid. So so let me teach you how I have done. Means how this code is. Means what is basically code, how this code is working in more efficient way. Let me explain you. So if you start doing brute force when if you do brute force, then its time complexity will be around n ki power big O big O of n, and it can exceed. And it is already given that k can be of 10 ki power 15 now, so it definitely failed the all cases. So see here, See here, we have this value is the mid value. Hmm. This given value is the mid value. Hmm. And the k is the, the what this k means. Means we have to find up to k. Hmm. So what I'm doing is, just for now ignore this this value this value plus is just to handle the edge cases. Hmm. So now I have initialized the value. Now I have an initialized this count. I have an initialized count with zero just to count the number of set bits. Suppose suppose they have given the x. What this x means that we need to only count that set bit which are at the position which are at the position of multiple of x. Hmm. So suppose if they have given x is equal to 2, if they have given x is equal to 2, now let me take this case. This will be good now. So let's take this case. So let's take this means, for x is equal to 2, we can only count the set bit present at 2, 4, sorry, yeah, 2, 4, 6, and 8. We can only count the set bit which are present at 2, 4, 6, 8, 10, like this, which are the multiple of 6. So what is the most efficient way to count the set bit? So just think, just see here. Hmm. We have already discussed that in the starting of the video. We have already discussed that at the first position, when we take the two elements, you must get the one set bit. Hmm. So if you take another two element, this is going to give you the one set bit. Hmm. In the case of second position, if you take the four element, this is going to give you two set bit. Hmm. So yeah, this is going to give you the two set bits. Hmm. So here, so what I'm doing here is that I have iterated over all the value of x from all the value of x. Initially, it was the initially I means I have iterated over all the value of x, all the multiple of x. I have just means at the in the condition I have increased the value of I bit, the value of so that I can so that we can iterate over each and every multiple of x. Hmm. After that, what I have done is I have initialized a div with long data type, and what I've done here is that just see here. Hmm. Just see here. This is the first binary, so first bit position. This is the second bit position. This is the third bit position. Hmm. This is the fourth bit position, and this is the fifth bit position. The thing you get to know is that that in when 2 ki power 1, and if you take 2 ki power 2, means when you take 2 ki power 1 elements from starting from 0, you will get only one set bit in the case of first position. Hmm. Suppose you have taken 16, 16. No, suppose you have taken 15, 15. You have taken 15. Yeah. Suppose you have taken 15. Now we are starting with 0 now. Starting with 0, we are starting with 0 now. We are starting with 0 now. So that's why the number of element will be 16. So we need to increase the value of 15 with 1. So we have to add 1 so that we can get the exact number of set bit. Hmm. So now what we are doing is we are just counting the number of set bit. The at number of set bit at position 1 from range 0 to 15. What this is a thing which I am doing now. Huh? So just be careful because it's quite complex. So what I'm doing here is that I'm just what I have done here is that, so here is, this is the first bit position, so I have done 2 key power 1. This is the second bit position, so I have done 2 key power 2, which is going to give you 4. Hmm. There is a reason for doing all these things. So be have a patient and wait for the results. I'm going to show you. Go show you the magic. So what I'm doing here is that I'm going to show you how to count the set bit from range 0 to from range 0 to 15. Hmm. So why I'm so so number presenting between 0 to 15 is that inclusively there will be 16 number including 0. So that's why I have done here 15 plus 1. So the number will be 16. So how we can get the number of set bit at position one is just by dividing this number of digits, means number of digits in the range divided by 2 key power bit position, which is 2 key power bit position. This is a formula. By doing this, you can get the value 8. So let's count it manually and see is there 8 set bit in between 0 to 15. Now I'm counting here. Here is 1, here is 2, here is 3, here is 4, here is 5, here is 6, here is 7, here is 8. So yes, there is 8 set bit. Now let's count the number of set bit between 0 to 15. 0 to 15 at second position. So for second position, I have already done 2 to the power 2, which is equal to 4, and number of digits. So how many number are there between in the range? So number we have already calculated, which is 15 plus 1. So number in the range is 16. Now dividing 16 by 4, 16 by 4. What we are going to get? Tell me. We are going to get the value 4. So from this equation, from this calculation, what we get to know that then there will be 4 set bit. Let's count it. Hmm. Not. Let's count. So 1, 2, 3, 4, 5, 6, 7, 8. So what we see here is that there is 8 set bit. So the formula is going to be formula going to be have some changes, because what we get here from calculation is that there will be 4 set bit, and now by doing manually checking manually, it shows that there is more than 4, which is 8 set bits. What we have to do is we have to just divide and need to multiply with. So previously we have seen that if we take value 4, what we are doing? We are counting the number of digits. We are counting the number of digits, and then we are counting the number of digits and with value 4. So what does it mean that in in 4, if you take a starting 4 element, you're definitely going to get the 2 set bit. So in the next 4, you're always going to get a 2 set bit. So this pattern follows until the number overflows the integer value or the long value. Means it is true for all the cases. So what here we get is that there is the fourth term, means there is the fourth term which is going to give us the two pairs of set bits. So there will be two pair of set bit, which is equal to 8. So here we are learning to how to derive the formula to here we are learning to how to derive the formula just to count the number of set bits. I will explain you each and every case. So now for counting the number of set bits from 0 to 15 at position third. Ah, at position third. So where we are. So basically, when we have to count the number of set bits in between range 0 to 15 at third bit position is what we have to do. We have to divide the number with total number in between range 0 to 15 by 8. So what here we are going to get is we are going to get 2. Hmm. So here we are going to get here we are here we get here we get 2. So for now, what we will what we get to see that if we count manually, we get to see that there is four set bit and there is another four set bit. So there is total number of eight set bit. So for correct calculation, we need to multiply this two with four, and from this you get to know that you get to know that there is pattern. You get to know that there is a pattern. So what is pattern? There is a pattern. So pattern is that after division we get certain number and we need to multiply with the previous we need to multiply with suppose let's see the formula. Let's see here. Let's see here. Let's see here. Wait, guys, wait. See here. What I have done here. I've just divided. Just I have done the division. And initially I have increased the value by one, and after that I have done the division after I have done the division of this value with this div. What this div is the what is this div? What this div holding? Div is holding basically the power of 2. So here I have increased the value by 1, and after that I have performed a division. So I have dividing the value with the division, which is the power of 2, and here power of 2 is the uh, binary position of which we are finding. So with this what we are going to get here is so with this we are going to get this value, this division value, and after that what we have to do, we have to multiply it with the value 4. So initially we have for this case for the first position we have multiplied it with 1, and for second bit position we have multiplied it with 2, and for third bit position we have multiplied it with 4, and if you do for fourth bit we have to multiply it with 8. So this is a basic. So basically this is the so this way we can solve this question. We can count the number of set bit. So here it is. A is the division value and multiplied with what is right. Mm, I have just with shifted the division value with division number by 1 bit. So suppose here x is equal to 4. So what this division value going to hold is that 1 key power 1 key power number 1 shifted right by 4. Number 1 shifted right by 4 means number 1 is represented by So initially number one is represented by 0, 0, 0, 0, 1. And if you shift each bit by 4, now this one going to be 1, 2, 3, 4. This one going to be this one going to be left by 4 position. Now this going to after this performing this operation, this going to hold this value in decimal format, which is 16. So this going to hold 16. Hmm. And if we perform the right operation, then one going to shift towards right, one going to shift towards right. It's going to hold the value 8. This is what we have to do. So this is what we have to do. So after one means what? So and there is one more case is that here we have taken from range 0 to 15. Suppose if we have taken from range from range 0 to 12, which is not multiple of either 2 or either 8, which is not multiple of either, means just see if we have taken between 0 to 12, what will be the number, what will be the total number. Hmm. Total number will be 12 plus 1, which is equal to 13. And for one number of set bit will be for one number of set bit will be 13 divided by 2, which is 6. Hmm. Which is 6. Which is 6. 1, 2, 3, 4, 5, 6. And if we check the second bit, number of set bit will be, we need to divide it by 4, which is going to be 3. 1, 2, 3, 4, 5, 6, means 3 multiplied by 2, what we have done earlier here. So there will be 6 set bit. If we check about the third bit position, what we get here is 13 divided by 8. 13 divided by 13 divided by 8. It's going to return the value 1. And value 1 multiplied by 4. For third bit, we have to what we have to do? We have to just multiply by 2 to the power 3 minus 1, which is 2, which is 4. Means 2 to the power 2 is 4. So it's going to return 4 set bit. Means what according to formula, it's going to return the 4 set bit. So in the range 0 to 12, there will be 4 set bit at the third position. Let's count it. 1, 2, 3, 4. There is no set bit, no set bit. No, yes, we get here another set bit in the range between 0 to 12. To just to just overcome these cases, what we have done here is we have just counted here. To just overcome these edge cases, what we have done here is I have just what I have done is that I have counted only this division. After that, I have multiplied with this. Means so it will be clear that we are going to get in trouble if we found the cases where they are not in the range. Means so uh, see here what I have done. I will just divide value by division. What is division? So you can see here in the third bit position, 2 to the power 3 is 8. So if we take 8 number from starting, we definitely going to get the 4 set bit. If we take another 8, we are again going to get a 4 set bit. But if we take instead of 8, if we take 4, we never get a any set means we are never going to get any single set bit. So after removing this four, whatever be the number if you take, suppose if you take two, then there will be two set bit. If you take three, there will be one more, means extra two plus one, which is three set bit. So these are the things which I have done. After division, the remainder. Here we have stored the remainder, and after storing remainder, I have just subtracted it with one lesser value because here we have calculated that every 8 contain 4 set bit. So in previous term, what we have done, every 4 contain 2 set bit. So we here what we see that after 8 there will be 4 where there is no set bit, which is equal to this term. You can relate now, bro. You are such a senior developer, then since you are such a, these things are so not a common, but you try to understand. So here I have just here I have done the subtraction of the 4. If it is greater than 0, then what is going to return is the value divided by the div. Here it is div. If it is less than 0, then it's going to return the value 0. So through this way we can count the number of set bits. I'm sorry because from my side I feel that I not have explained much clear way. So let me explain you the last time what the concept, what the case. See here, at first at first position, at first bit position is one. First bit position we can find a 2 key power 1, 2 key power bit position. Hmm. This is the this is bit position. So at first bit position, if you take two numbers, there will be definitely be one set bit. If you take another two, there will be another set bit. If you take one, then it's not going to contain any set bit. So just to handle these cases, I have written this code. Now you can relate. If we talk about this fourth bit, let's talk about a three bit position, third bit position. 2 to the power 3 is 8. If you take 8 bits, 8 numbers, 8 numbers, it is definitely contain the 4 set bit. If you take another 8, it contains 4 set bit. So from this you get to know that starting of 8 contains 4 set bit. If you take in between, if you take any number which is not a which is not divisible by 8, it definitely going to have some edge cases. So just to handle that cases, I will end this code. So now you can relate how this how this code is going to handle that cases. And the same way, suppose if x is equal to 2, here x is equal to 2, I am going to do is I am going to iterate over each value of x. Is x each value of multiple of x. Initially I am starting with 2, then with 4, then I will continue till I will be less than 53. In each iteration, what I am going to do is I've just counted the number of set bit at that position. At the end, at the end, at the end, if count value is greater than or equal to k, what we are going to return? We're going to return true. If it is less than or equal to k, it's going to return false. So this is the operation function. What this operation function do? So this is going to return whether this satisfied the value. This this function going to return whether the given condition in the question satisfied or not. If it is satisfied, then this question basically is the binary search question. At the end, we will get the we will get the result, we will get the binary operation, we will get the value means we will get the number n which satisfy the cases. uh, and I think that's enough from my side. I think I have done. I'm not able to explain this question. So sorry from my side. I will try hard next time to improve my skills, improve this explanation skill. So sorry from my side, guys. So for now, bye and have a good time, and be happy.